I'm thrilled to begin our journey into the world of Python programming today. This comprehensive course will transform the way you think about coding and data analysis. In Module 1, we're focusing on the essential foundations of Python, the building blocks that will support your entire programming journey. You'll notice the Python logo at the bottom right of our slide. That friendly blue and yellow symbol represents one of the most versatile and accessible programming languages in use today. What makes this module particularly exciting is that we're starting from the ground up. Whether you're completely new to programming or have some experience with other languages, these fundamentals will ensure you have a rock-solid foundation to build upon. Over the next 44 slides, we'll explore everything you need to get started with Python, from installation to writing your first lines of code. We'll be working with Analytica Data Science Solutions' proven methodology, which has helped countless professionals master Python programming. Looking at our date of December 2024, we'll be using the latest stable version of Python, ensuring you're learning with current best practices and tools. So, let's begin this exciting journey into the world of Python programming together. Today marks the beginning of our journey into Python programming. Python stands as one of the most versatile and accessible programming languages in today's tech landscape. Throughout this comprehensive course, we'll explore everything from basic syntax to advanced applications, building a solid foundation for your programming journey. The beauty of Python lies in its readability and straightforward syntax. As we progress through these sessions, you'll discover why Python has become the go-to language for data science, web development, artificial intelligence, and countless other applications. I've structured this course to be both engaging and practical. Whether you're completely new to programming or have experience with other languages, you'll find our approach methodical and thorough. Looking at our course logo in the corner, you can see Python's distinctive blue and yellow emblem, a symbol that represents both the simplicity and power of this programming language. This visual reminder will accompany us throughout our learning journey. Remember, programming is a skill best learned through practice and persistence. So, let's begin this exciting adventure into the world of Python programming together. In this comprehensive Python programming course, I'm excited to outline exactly what you'll master and how we'll structure your learning journey. On the learning side, we'll begin with complete Python fundamentals. These are the building blocks that will form your programming foundation. We'll then progress to real-world applications, ensuring you're not just learning theory, but practical implementations that matter in today's industry. I've carefully designed this course to emphasize best practices from day one, because it's much easier to develop good habits from the start than to correct bad ones later. You'll also gain exposure to industry-standard techniques that employers actively seek in Python developers. The course structure is thoughtfully organized to maximize your learning. We'll work through weekly modules that build upon each other naturally. Each module includes hands-on exercises, because programming is not a spectator sport. What I'm particularly excited about are the real projects we'll tackle together. These aren't just academic exercises. They're practical applications that demonstrate how Python solves real-world problems. Our interactive sessions will give you the opportunity to ask questions, debug code together, and learn from your peers' challenges and successes. Remember, this course isn't just about learning Python syntax. It's about becoming a capable, confident programmer who can tackle real-world challenges effectively. Before we dive into the technical aspects of Python, I'd like to set clear expectations for this module. These learning objectives represent the core competencies you'll develop over the next few hours. First, you'll gain a solid understanding of Python's position in today's programming landscape, why it's become so influential, and where it truly shines. We'll then guide you through setting up a professional development environment, ensuring you have all the tools needed for efficient coding. The heart of our module focuses on practical skills, writing and executing Python code effectively, mastering fundamental data types, and handling user interactions professionally. You'll also become familiar with Python's powerful built-in functions. These are the building blocks that will make your coding journey much smoother. And because every programmer needs to troubleshoot, we'll cover essential debugging techniques to help you solve problems efficiently. Think of these objectives as your roadmap. By the end of this module, you'll have a solid foundation in Python programming, ready to tackle more advanced concepts. Remember, each objective builds upon the previous one, creating a comprehensive understanding of Python basics. Today's programming landscape offers many languages, but Python stands out for several compelling reasons. Looking at our slide, you'll notice Python's distinctive blue and yellow logo, representing one of the most accessible yet powerful programming languages available. What makes Python particularly special is its high-level and readable syntax. It's practically like reading English, which significantly reduces the learning curve. The language's versatility and power cannot be overstated. From web development to artificial intelligence, Python handles it all. It has become an industry standard, especially in data science and machine learning. One of Python's greatest strengths is its extensive ecosystem. Think of it as a massive toolbox. Whatever you need to build, there's likely a library for that. The rapid development capability means we can create functional programs in fewer lines of code compared to other languages. Being cross-platform, your code runs seamlessly across Windows, Mac, or Linux. Two final points that make Python particularly attractive. It's completely free and open source, and it's backed by one of the most active and helpful programming communities in the world. These characteristics combine to make Python an excellent choice for both beginners and experienced developers. Throughout this course, you'll experience firsthand why these features make Python such a powerful tool for modern programming. Python's versatility truly shines through its four major application domains, which we can see beautifully illustrated on this slide. In web development, we have powerful frameworks like Django, Flask, and FastAPI. These tools enable us to build everything from simple web applications to complex enterprise-level systems. Moving to data science, three essential libraries form the backbone of any analysis. Pandas for data manipulation, NumPy for numerical computations, and Matplotlib for creating insightful visualizations. These tools have revolutionized how we handle and interpret data. The AI and machine learning domain showcases Python's cutting-edge capabilities. TensorFlow, PyTorch, and scikit-learn represent the gold standard in machine learning frameworks, powering everything from basic classification tasks to deep neural networks. Finally, Python excels in automation and DevOps. Through scriptings, testing frameworks, and DevOps tools, we can automate repetitive tasks and streamline development workflows, significantly improving productivity. What makes Python particularly remarkable is how these domains often overlap and complement each other. For instance, you might use web development frameworks to deploy your machine learning models, or automation tools to streamline your data science workflows. These applications demonstrate why Python has become the go-to language for both beginners and experienced developers across multiple industries. Before we can begin our Python journey, we need to ensure everyone has the proper tools installed. The setup process is straightforward and consists of just two main steps. First, head over to python.org to download Python 3.x. I recommend getting the latest stable version. During installation, there's one critical checkbox you shouldn't miss. Add Python to path. This option makes Python accessible from anywhere on your system. Once the installation is complete, We'll verify everything is working correctly. Open your command prompt or terminal and type Python version. This command, which you can see displayed in the dark terminal window on the slide, will show you which version of Python is installed on your system. If you see a version number in response, congratulations, you've successfully installed Python. If you encounter any issues during installation, don't worry, we'll troubleshoot them together. The most common problem is forgetting to check the path option, but that's easily fixed by running the installer again. Remember, having a proper installation is the foundation for everything we'll do in this course, so it's worth taking the time to get this right. Setting up our development environment is a crucial first step, and we'll be using Visual Studio Code or VS Code as our primary code editor. First, head over to code.visualstudio.com to download VS Code. It's a free, lightweight, yet powerful editor that's perfect for Python development. Once you've installed VS Code, you'll need to add the Python extension. This gives us essential features like syntax highlighting, code completion, and debugging capabilities. After installation, there are two key configuration steps we need to complete. Select your Python interpreter. This tells VS Code which version of Python to use when running your code. Then, enable Format on Save. This is a fantastic feature that automatically cleans up your code formatting whenever you save your files, helping you maintain consistent, readable code. Here's a pro tip that will save you time. Use the integrated terminal in VS Code. It's right there in your editor, meaning you won't need to switch between different windows while coding. You can access it by pressing Ctrl+, backtick, or through the View menu. These setup steps might seem basic, but they lay the foundation for a smooth and efficient coding experience throughout our course. Take your time to get comfortable with the VS Code interface. You'll be using it extensively as we progress. In this pivotal section, we're going to explore the fundamental building blocks of Python programming: data types. Think of data types as the different categories of information our programs can work with, much like how we categorize things in the real world. Our objectives here are comprehensive but straightforward. First, we'll examine Python's core data types, the essential tools in our programming toolkit. Then, we'll dive into type checking and conversion, which is crucial for writing robust code that handles different kinds of data correctly. Through hands-on practice, you'll gain confidence working with various data types, from simple numbers to more complex structures. Finally, we'll master the basic operations you can perform with these types, the fundamental manipulations that form the backbone of Python programming. By the end of this section, you'll have a solid foundation in how Python organizes and handles different kinds of data, setting you up for success in more advanced programming concepts. Remember, understanding data types isn't just about memorizing categories. It's about knowing how to use the right tool for the right job. In Python, we build our programs using several fundamental data types, and today I'll walk you through the most essential ones. Looking at our code examples, we have our numeric types on the left. The integer value 42 represents whole numbers with no decimal points. These can be as large as your computer's memory allows. Floating point numbers, like 3.14, give us those crucial decimal values, though they're limited to about 15 to 17 digits of precision. For advanced mathematical operations, we have complex numbers, shown here as 1 plus 2j, where j represents the imaginary component. Shifting to the right side of our slide, we see other vital data types. Strings like Python handle all our text processing needs. Booleans, represented by true or false, are essential for control flow and decision making in our programs. And don't overlook none. It's Python's way of representing missing or undefined values, which becomes particularly important when working with real-world data. What makes these data types so powerful is their built-in functionality and interoperability. Each type comes with its own set of methods and operations that we'll explore in more detail as we progress through the course. Understanding these basic building blocks is fundamental to writing effective Python code. Understanding type conversion in Python is essential for effective data manipulation. Looking at this flowchart, I'll walk you through how Python handles different type conversions. At the top, we start with any input value, and Python first determines its type. The flowchart branches into three main pathways: string, number, and Boolean. For string values, if we need to convert them to numbers, Python checks for valid digits. When valid digits are present, we have two possibilities. Numbers with decimals go through float, while whole numbers use int. If the string doesn't contain valid digits, we get a value error. For number types, both integers and floats, conversion to strings is straightforward using string. This is a safe conversion that always works. Boolean values follow a simple rule. True converts to 1 and false converts to 0 when converting to numbers. Notice the color coding in our rules box. Green indicates safe conversions, yellow warns of potential data loss, and red highlights error-prone operations. Python handles these conversions either implicitly, doing it automatically, or explicitly when we use type functions. Remember, while Python is flexible with type conversion, it's crucial to understand these pathways to avoid unexpected errors in your code. Always validate your data before attempting conversions, especially when dealing with user input or external data sources. Understanding operator precedence in Python is absolutely essential for writing reliable code. Looking at our hierarchy diagram, we can see that operations follow a clear top-to-bottom order. At the highest level, we have parentheses, which always execute first and can override the default precedence rules. Below that comes exponentiation with the double asterisk operator. Then multiplication and division share the same precedence level, including floor division and modulo operations. Finally, at the bottom, we have addition and subtraction. Let's examine our example. 2 plus 3, 4, 2. Without parentheses, Python follows the precedence rule strictly. First, it evaluates 4 on 2, which equals 16. Then it performs 3 on 16, giving us 48. Finally, it adds 2, resulting in 50. Here's a critical tip. When in doubt, use parentheses. They not only ensure your calculations execute in the intended order, but also make your code more readable for others. Remember, operations at the same level execute from left to right, but explicit is always better than implicit in Python. Think of operator precedence like a recipe. You wouldn't add ingredients in random order and expect the dish to turn out right. The same applies to mathematical operations in your code. Understanding how Python executes our code is fundamental to becoming an effective programmer. Looking at this flowchart, I'll walk you through the journey our code takes from writing to execution. The process begins at the top with our source code. When we run our program, the Python interpreter first takes control. The interpreter performs a syntax check. This is our first gateway. If the syntax is valid, the code is compiled into bytecode. However, if there's an invalid syntax, we'll receive a syntax error, and the execution stops right there. Assuming our syntax is correct, the code moves to the Python virtual machine. Here, we encounter our second checkpoint, the runtime check. This is where Python actually tries to execute our instructions. If everything is valid, the code executes successfully. If not, we get a runtime error, and Python asks if there's more code to process. On the right side of our slide, I've highlighted some critical understanding points. Code always reads from top to bottom. Functions must be defined before they can be called. Import statements are processed first. Main execution follows these preliminary steps. Scope rules determine variable accessibility. Think of this flow like security checkpoints at an airport. Each stage ensures our code is safe and properly formatted before moving to the next level. Understanding this process helps us debug more effectively and write more efficient code. Error handling represents one of the most critical aspects of robust Python programming. Looking at this flowchart, I'll walk you through the typical error handling pathways that every Python program should implement. The process begins at program start, flowing into a try block execution. When an error occurs, Python immediately evaluates the exception type, branching into four distinct handlers: value error, type error, zero division error, and a general exception handler as our safety net. What's particularly important here is how each error type receives specialized treatment. For instance, if a user inputs text where we expect numbers, the value error handler manages that specific scenario. Similarly, division by zero gets its dedicated pathway through the zero division error handler. After error detection, our program reaches a crucial decision point: can recover. If recovery is possible, we execute recovery code and resume program flow. If not, we log the error and exit gracefully. Notice how all paths eventually converge at next code block. This demonstrates the fundamental principle of maintaining program flow integrity, regardless of whether we encounter errors or execute successfully. The yellow boxes highlight our action points. These are the concrete steps our code takes to handle, log, or recover from errors. This systematic approach ensures our applications remain stable and user-friendly, even when things don't go as planned. Remember, effective error handling isn't about preventing all errors. It's about managing them gracefully when they occur. This pathway diagram serves as our blueprint for implementing robust error management in Python applications. Moving into the heart of our Python fundamentals, we're focusing on number operations, the building blocks of computational programming. In this crucial section, I'll guide you through four essential components that will form the foundation of your Python arithmetic skills. First, we'll master basic arithmetic operations, the core four, as I like to call them: addition, subtraction, multiplication, and division. Then, we'll explore operator precedence, understanding how Python decides which calculations to perform first, just like the order of operations you might remember from mathematics. Third, I'll show you how to leverage Python's math module, a powerful toolkit that extends our mathematical capabilities beyond basic arithmetic. Finally, we'll put it all together by practicing common numerical operations you'll use frequently in real-world programming scenarios. Think of this section as your mathematical Swiss Army knife in Python. By the end, you'll have all the tools you need to handle numerical computations confidently. Let's begin with the fundamentals of arithmetic operations. Moving into the fundamental building blocks of Python programming, let's examine basic arithmetic operations. In this code example, I've initialized two variables: x with a value of 10 and y with a value of 3. Looking at the output comments on the right, we can see exactly what each operation produces. Addition using the plus operator gives us 13, while subtraction with the minus operator results in 7. Multiplication, denoted by the asterisk symbol, yields 30, which makes sense as we're multiplying 10 by 3. The division operator, represented by the forward slash, produces approximately 3.333, since we're dividing 10 by 3. Notice how we're using formatted string literals, or f-strings, to display our results. This is a clean and efficient way to show both the operation and its result. One quick tip about these operations: remember to consider operator precedence when combining multiple operations. Just like in regular mathematics, multiplication and division take precedence over addition and subtraction unless parentheses are used to specify otherwise. These basic arithmetic operations form the foundation for more complex calculations we'll explore later in our course. Moving deeper into Python's number operations, I'll highlight some advanced features that are essential for your programming toolkit. Looking at our code examples, we have three powerful operations displayed at the top. Floor division, shown with the double / operator, gives us the quotient without any decimal places. The modulus operator, using the percentage symbol, returns the remainder after division, incredibly useful when you need to check if numbers are even or odd or when implementing circular behaviors. For exponential calculations, Python uses the double asterisk. As shown in our example, this can compute large numbers efficiently. Notice how we get 1000 as the output. The math module brings additional mathematical precision to our programs. We can calculate square roots using math.sqrt. See how it gives us 4.0 for the square root of 16. And for those working with geometric calculations, we have math.py providing the value of p to high precision. Now, here's something critical to remember. I've included 3 common pitfalls at the bottom of the slide. Never divide by 0. Python will raise a 0 division error. Remember that integer division in Python 3 always returns a float. When comparing floating point numbers, always use math is close for accuracy. These pitfalls might seem basic, but they're often the source of subtle bugs in production code. In this crucial summary of number operations, I'll highlight the essential points you'll need throughout your Python journey. The basic arithmetic operators in Python are exactly what you might expect from mathematics. We have addition with plus, subtraction with minus, multiplication with asterisk, division with /, modulo with percent, and exponentiation with double asterisk. For more sophisticated mathematical operations, Python provides the math module. It's like having a scientific calculator built right into your code. Here's something critical to remember. Division by 0 will crash your program. Python can't perform this operation, so we always need to implement checks to prevent this error. Finally, operator precedence follows the same rules as mathematical operations. Think PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. When in doubt, use parentheses to make your intentions explicit. These fundamentals form the backbone of numerical computations in Python, and you'll find yourself using them in virtually every program you write. Time for a quick knowledge check to reinforce our understanding of number operations in Python. Looking at our first question, we're dealing with floor division, 15 divided by 4. The result is 3, and it's important to note that floor division always rounds down to the nearest integer. For our second problem, we're evaluating the expression 2. 3 plus 1. Remember our order of operations, exponents before addition. So we'll calculate 2 to the power of 3, which is 8, and then add 1, giving us 9. The third question tests our understanding of the modulo operator. When we calculate 10% 3, we're looking for the remainder after division. In this case, it's 1. Finally, we have an interesting question about division. Will 5/2 return an integer? The answer is no. It returns 2.5, a float. This highlights a key difference between regular division, root, and floor division, or in Python. These operations form the foundation of numerical computations in Python, and you'll find yourself using them frequently in real-world programming scenarios. Take a moment to practice these if you need to build more confidence with these fundamental operations. Strings are fundamental building blocks in Python programming, and in this section, we'll explore their incredible versatility. I'm excited to guide you through 4 essential aspects of string operations that will significantly enhance your Python programming skills. First, we'll dive deep into string manipulation. learning how to slice, concatenate, and transform strings in ways that give you precise control over text data. Next, we'll master various string methods. These are the powerful tools built into Python that allow you to search, replace, and modify strings effortlessly. The concept of string immutability is particularly fascinating. It's a core characteristic that affects how we work with strings in Python. Understanding this principle is crucial for writing efficient code and avoiding common pitfalls. Finally, we'll practice string formatting. I'll show you multiple approaches to format strings beautifully, from the classic percent operator to the modern F strings. This skill is essential for creating clean, professional output in your programs. By the end of this section, you'll have a comprehensive understanding of how to work with strings effectively in Python. String operations form the backbone of text processing in Python, and today we're diving into their essential features. Looking at our code example, I've initialized a simple string variable containing Python programming. Let me walk you through the fundamental operations we can perform on this text. First, we can retrieve the original text using a basic print statement. Next, using the len function, we can determine the string's length, in this case, 17 characters. Two particularly useful methods are upper and lower, which transform our text to uppercase and lowercase, respectively. Pay special attention to the key features highlighted in our blue box. Strings in Python are immutable, meaning once created, they cannot be changed. They fully support Unicode characters, and they're treated as sequence types, allowing us to access individual characters. For best practices, and this is crucial, I strongly recommend using F strings for string formatting. You can see this in our code examples where we use the F prefix. Whether you choose single or double quotes, consistency is key. Stick to one style throughout your code. And remember to always consider built-in string methods as your first solution before implementing custom string manipulation. These fundamentals will serve as building blocks for more advanced string operations we'll explore later in the course. String operations in Python offer powerful text manipulation capabilities, and today we're diving deeper into some essential techniques. Looking at our code example, we're working with the text Python programming. Let me walk you through each operation and its output. First, the split method automatically divides our text into a list wherever it finds a space. When we run text split, we get Python programming, two separate elements in a list. For accessing specific parts of our string, we use slicing. With text init, we extract just Python, and with text, we get programming. This demonstrates how we can precisely select portions of our text. One particularly interesting operation is text, which reverses our entire string. Notice how Python programming becomes gnimargp nodp. This is a common Python trick that's incredibly useful for certain text processing tasks. Finally, we see the replaced method in action, where we are substituting Python with advanced. This transforms our string into advanced programming. At the bottom of our slide, you'll notice the slicing syntax breakdown: text, start, end, step. Think of this as defining where to begin, where to end, and how to move through the string. This pattern is fundamental to Python string manipulation. Remember, these operations are immutable. They don't change the original string, but create new ones instead. This is a key concept in Python string handling. Moving on to string operations, I'd like to highlight some key concepts that form the foundation of text manipulation in Python. First and foremost, it's essential to understand that strings in Python are immutable sequences. Kichi. This means once we create a string, we cannot modify individual characters within it. Any operation that appears to modify a string actually creates a new one. Let's explore the common methods we'll be using frequently. The upper and lower methods transform text case, while split breaks strings into lists and replace substitute specified characters or substrings. I'll demonstrate these shortly with practical examples. When we need to work with portions of strings, we use slicing with the start.end step syntax. Think of it as defining a window through which we view only the characters we need. Finally, I want to introduce f-strings for formatting. They're a game changer for string manipulation in Python. They allow us to embed expressions inside string literals, making our code both more readable and maintainable. We'll practice using these concepts in our upcoming exercises. Time for a quick knowledge check on string operations. Looking at our first question, we're examining Python. This is a perfect example of string slicing. The answer is yth, as we start at index 1 and go up to, but not including index 4. Moving to our second challenge, we're testing the upper method with hello. This transforms the string to hello, a straightforward but essential string manipulation technique. The third question explores string joining, combining A, B, and C. Using the join method, we create ABC. This demonstrates how we can concatenate multiple strings efficiently. Finally, we're looking at len Python. Notice the space after Python. It's crucial to remember that spaces count as characters in string length calculations. The answer is 7, as we have 6 letters plus 1 space character. These operations form the foundation of string manipulation in Python, and you'll use them frequently in your programming journey. Take a moment to verify your answers with the solutions provided at the bottom of the slide. Remember, string operations are case sensitive, and indexing always starts at 0 in Python. These are fundamental concepts you'll want to keep in mind. Input handling forms the backbone of any interactive Python program. In this crucial section, we're going to explore 4 essential aspects of managing user input effectively. First, we'll master the fundamentals of user input handling, understanding how to capture, process, and work with data that users provide to our programs. Next, we'll dive into input validation, which is absolutely critical for building robust applications. I'll show you techniques to ensure that the data entering your program meets your specified criteria and requirements. Third, we'll examine different error types you might encounter when handling user input. This knowledge is invaluable because, trust me, users will find creative ways to input unexpected data. Finally, we'll put theory into practice by working with error messages, learning how to create clear, helpful feedback that guides users when something goes wrong. By the end of this section, you'll have a solid foundation in defensive programming techniques that will make your applications more reliable and user-friendly. These skills will be particularly valuable when we build our calculator project later in the course. Input handling forms the backbone of interactive programming, and here we're examining a fundamental pattern for validating numerical input. Looking at our code example, we have a function called getValidNumber that takes a prompt parameter. This function implements a robust error handling pattern that you'll use frequently in your Python programs. The structure uses a while-true loop combined with a try-except block, a powerful combination for input validation. Here's how it works. The function continuously prompts for input until it receives valid numerical data. When a user enters something, we attempt to convert it to a float using the float function. If successful, the function returns the number immediately. However, if the conversion fails, say someone types hello instead of a number, it catches the value error and displays a friendly error message. What makes this pattern particularly effective is its persistence. It won't let users proceed until they provide valid numerical input, making our programs more reliable and user-friendly. Take special note of the docstring comments. They follow Python's best practices for documentation, clearly stating the function's purpose and parameters. This pattern will become second nature as you develop more Python applications. Remember to reference the error handling flowchart we discussed earlier. It provides a visual guide for understanding how this try-except flow works in practice. We'll build on this foundation as we move forward with more complex input handling scenarios. Continuing our exploration of input handling, I'll demonstrate a crucial function for obtaining valid numerical input from users. The getValidNumber function shown here serves two essential purposes. It returns a float when successful and none if the operation is cancelled. Let's examine the example in detail. When we call getValidNumber with the prompt enter a number, it waits for user input. If the user enters 42, the function successfully converts it to a float and returns 42.0. However, what makes this function particularly robust is its error handling. Notice the except keyboard interrupt block. This catches situations where users press Ctrl+C to cancel the operation. In such cases, we print operation cancelled and return none, providing a clean exit strategy. At the bottom of our slide, I've highlighted three common error types you'll encounter: value error, keyboard interrupt, and type error. These form the foundation of robust input handling in Python. For effective debugging, remember these three key tips. Use print statements liberally to track program flow, always check input types, and handle all possible exceptions. These practices will save you countless hours of troubleshooting later. This pattern of input handling is something you'll use frequently in your Python programs, especially when building interactive applications. Input handling forms the backbone of any robust Python program, and I'd like to highlight four essential practices that will make your code more reliable and user-friendly. First, always validate user input. This isn't just a suggestion, it's a critical defense mechanism that prevents your program from breaking when users provide unexpected data. Second, implement try-except blocks for error handling. Think of this as your code safety net. When something goes wrong, and trust me, with user input, things will go wrong, your program can gracefully catch and handle these errors instead of crashing. Third, provide clear error messages. This might seem obvious, but I can't stress enough how important it is to give users meaningful feedback. Instead of cryptic system errors, your messages should guide users toward the correct input format. Finally, don't forget to handle keyboard interrupts. Users expect to be able to exit programs using Ctrl+C, and your code should respond appropriately to these interrupts. These four practices work together as a comprehensive input handling strategy. By implementing them consistently, you'll create more professional and reliable Python applications that can handle real-world usage scenarios. Time for a quick knowledge check on input handling. I've prepared four key questions that will help solidify our understanding of how Python manages user input. Looking at our first question about invalid number input, the answer is value error. This exception is crucial to catch when converting string inputs to numbers. For handling Ctrl+C interruptions, we use the keyboard interrupt exception. This is essential when creating programs that need graceful termination options. Regarding error messages, I always emphasize keeping them clear and specific. This isn't just good practice. It's vital for both debugging and user experience. The final question addresses a common confusion: when to use float versus int. Here's the simple rule: float is your go-to for decimal numbers, while int is perfect for whole numbers. These distinctions might seem small now, but they become critical when building robust applications that handle user input effectively. Take a moment to review these answers and make sure they align with your understanding. Remember, proper input handling is the foundation of reliable Python programs. Time to put our Python knowledge into practice with an exciting hands-on project. In this section, we're going to build a simple calculator that will reinforce several key programming concepts we've covered. Our project has 4 essential components that we'll implement step by step. First, we'll create the basic calculator functionality, allowing us to perform fundamental mathematical operations. Second, we'll focus on implementing robust error handling, because in real-world applications, things don't always go as planned. This will teach you how to manage unexpected inputs and prevent your program from crashing. Third, we'll practice input validation techniques to ensure our calculator only processes appropriate data. This is a critical skill that you'll use in virtually every program you write. Finally, we'll polish our project by creating user-friendly output that makes our calculator intuitive and pleasant to use. This project isn't just about building a calculator. It's about understanding how different Python concepts work together in a real application. By the end of this section, you'll have created your first practical Python program from scratch. Let's begin with the first component and work our way through each requirement systematically. In this part of our calculator project, I'm introducing the core structure of our simple calculator function. Looking at the code, we've implemented several key design principles that make our calculator both robust and user-friendly. The function begins with a clear docstring explaining its purpose, followed by a clean interface setup using print statements to create a visual separator and title. What's particularly important here is our approach to error handling. Notice how we've structured the code with early returns. If num1 is none or if we encounter an invalid operation, the function exits immediately. This fail-fast principle is a crucial aspect of writing maintainable code. The input validation is especially noteworthy. We're checking for valid operations using a specific set of allowed operators: addition, subtraction, multiplication, and division. If the user enters anything else, they'll receive an invalid operation message, and the function will terminate cleanly. The modular structure we've implemented here serves as a foundation for more complex calculations. Each component, from number input to operation validation, is clearly separated, making our code easier to debug and maintain. Remember, this is just the first part of our calculator implementation. We're building these fundamentals to ensure our final product is both reliable and user-friendly. The principles we're applying here, clear user interface, early error returns, input validation, and modular structure, are patterns you'll use throughout your Python programming journey. Moving into the second part of our calculator implementation, we're focusing on error handling, a critical aspect of robust programming. Looking at the code snippet, I'll walk you through the key error handling mechanisms. First, we get our second number input using the getValidNumber function with a check to return if the input is none. The heart of our error handling lies in the try block where we perform our calculations. For addition, subtraction, and multiplication, the operations are straightforward. However, pay special attention to the division operation. We've implemented a crucial safety check. If num2 equals 0, we display an error, division by 0, message, and return from the function. This prevents our program from crashing due to the infamous division by 0 error. Below the code, you'll notice our error handling checklist. We're covering 4 essential types of errors: division by 0 checks, type validation, user interruption handling, invalid operation catching. These safeguards make our calculator bulletproof against common user input errors. Remember, good error handling isn't just about preventing crashes, it's about providing clear feedback to users when something goes wrong. In professional development, we call this defensive programming, anticipating and gracefully handling potential issues before they become problems. Looking at part 3 of our simple calculator implementation, I'll highlight some key aspects of the code structure. The code demonstrates proper result formatting using an F-string with 2 decimal places, which ensures our calculator outputs are consistently readable. We've implemented robust error handling using a try-except block, a critical feature for any production-ready application. When exceptions occur, our code gracefully displays user-friendly error messages instead of crashing. The example output shown here illustrates a multiplication operation, entering 10 as the first number, selecting the multiplication operator, and inputting 5 as the second number yields a result of 50. In the blue box below, you can see our key features include result formatting, error messages, and a main guard, all essential components for professional-grade Python applications. Looking ahead at potential extensions in the green box, we could enhance this calculator by adding more operations, implementing a history feature, supporting decimals, and including memory functions, similar to what you'd find in a standard calculator. These improvements would make excellent practice exercises for solidifying your Python skills. Remember, starting with a simple implementation and gradually adding features is a fundamental principle of good software development. Looking back at our calculator project, I'd like to highlight 4 essential takeaways that demonstrate the fundamental programming principles we've mastered. First, we implemented a structured program design, breaking down our calculator into clear, logical components that work together seamlessly. This approach makes our code not just functional, but also maintainable. The second key achievement was incorporating comprehensive error handling. We anticipated potential user mistakes, like division by 0 or invalid inputs, and built robust safeguards to handle these gracefully. Third, we prioritized creating a user-friendly interface. While it may be a command line application, we ensured clear prompts, informative messages, and intuitive operation flow. Remember, good code isn't just about functionality, it's about user experience too. Finally, we practiced modular code organization, separating our calculator's functions into logical units. This modular approach isn't just about keeping our code tidy, it's about making it scalable and easier to debug. These 4 principles form the foundation of professional-grade programming, and you'll continue to apply them in increasingly sophisticated ways as we progress through the course. Time for a quick knowledge check on our calculator project. I've prepared 4 key questions that will help solidify our understanding of the core concepts we've implemented. The first question addresses a critical safety feature: why we check for 0 before division. This is essential for preventing our calculator from crashing. Second, we'll explore the benefits of using functions in our code. This ties directly into our discussions about code organization and maintainability. Our third question examines the reasoning behind returning none when an operation is canceled, a subtle but important design decision that impacts user experience. Finally, we'll look at how to extend the calculator's functionality, which is crucial for those wanting to build upon this foundation. For those following along, I've included the solutions right below each question. Notice how each answer is concise yet comprehensive. Preventing 0 division error, emphasizing reusability and organization, handling canceled operations, and adding new operations to our operations dictionary. These concepts form the backbone of robust program design, and understanding them will serve you well in future projects. Take a moment to review these points and ensure they align with your implementation. Perfect timing for a comprehensive review of what we've covered in Module 1. Looking at our core concepts first, we've mastered the fundamental building blocks of Python programming: data types and operations. We explored numbers, strings, and booleans, learned how to convert between different types, and practiced basic operations that form the foundation of any Python program. String manipulation has been another crucial focus area. We've covered everything from methods and formatting to slicing and indexing, skills you'll use in virtually every Python project you create. In terms of practical skills, we've developed robust input/output handling capabilities. This includes taking user input, managing errors effectively, and implementing proper input validation, all essential components of professional grade programming. The calculator project brought everything together, allowing us to apply these concepts while learning about proper code organization and best practices. Looking ahead to Module 2, we'll build on these foundations by diving into control flow, functions, and data structures. Before we move forward, please complete your homework assignments and review the practice exercises to solidify your understanding. Remember, these fundamentals we've covered are the building blocks for everything else you'll learn in Python programming. Take time to practice and really cement these concepts before we advance to more complex topics. Time to put your Python skills to the test with 3 engaging code challenges focused on data types. For our first challenge, we're working with a fascinating string-to-integer conversion puzzle. Looking at the code, we have x$42, followed by string concatenation and integer conversion operations. I'll give you a moment to predict the output. The solution reveals that z equals 386, which comes from converting 428 to an integer and subtracting 42. Moving to challenge 2. We encounter a common error when combining strings and numbers. The code attempts to concatenate Python with 3.14, which won't work directly. The fix is straightforward. We need to convert the number to a string first using str_num. This is a critical concept in Python programming. For our final challenge, we're exploring Boolean values with 3 different scenarios. We're converting an empty string, a list, and a float to Boolean values. This demonstrates how Python handles truth values for different data types. The solution shows false, true, false, highlighting that empty containers and 0 values are considered falsy in Python. These challenges reinforce fundamental concepts about type conversion and truth values in Python. Take a moment to try these exercises yourself. They're excellent practice for real-world programming scenarios. Time to put our string manipulation skills to the test with 3 engaging challenges. In our first challenge, we're working with acronyms. Looking at the code, we take the text, Python for Beginners, and create an acronym by extracting the first letter of each word. The solution elegantly uses list comprehension with split and upper methods to generate PFP. Moving to our second challenge, we tackle word reversal. The input sentence, "Hello Python world," needs to be transformed into "world Python hello." Notice how our solution uses split to break the sentence into words, then reconstructs them in reverse order using slice notation. The 1. For our final challenge, we explore string formatting. We're working with 2 variables, a name and an age, that need to be combined into a formatted string. The solution demonstrates the use of f-strings, a powerful Python feature introduced in version 3.6, to create clean, readable output. These challenges showcase 3 different aspects of string manipulation: character extraction, word ordering, and string interpolation. Take a moment to study how each solution uses Python's built-in string methods efficiently. The techniques demonstrated here are fundamental building blocks you'll use frequently in real-world programming. Time to enhance our calculator with some powerful new features. Looking at our code challenge, we're going to implement 4 key improvements that will transform our basic calculator into a more sophisticated tool. First, we'll add the power operation using the double asterisk syntax in Python. As you can see in the solution code, we've implemented this using a lambda function with xsec to handle exponentiation. The square root functionality comes next, which we've cleverly implemented using the power operation with zero point 0.5 as the exponent, a neat mathematical trick that gives us precise results. One of the most practical additions is the memory function. Notice how we've added two new operations, m plus for storing values and mr for recalling them. The memory is initialized as 0 in our constructor, and we've created dedicated methods, store memory and recall memory, to manage this functionality. Finally, we're tracking calculation history using a simple list structure. The add to history method appends each calculation, allowing users to review their previous operations. The solution demonstrates clean, efficient code organization with clear separation of concerns. Each new feature is implemented as a distinct operation in our operations dictionary, maintaining our calculator's modular design. Take special note of how we've used Lambda functions throughout the implementation. They provide a concise way to define our operations while keeping the code readable and maintainable. Time to put our Python skills into practice with two engaging projects. On the left, we have a temperature converter project, a practical application that converts temperatures between Celsius and Fahrenheit. This project will help you master several key programming concepts: input validation to ensure users enter valid numbers, formatted output to display results clearly, and proper error handling for robust code. On the right, we're building something more entertaining, a number guessing game. This project incorporates random number generation, user input handling, and score tracking across multiple difficulty levels. It's an excellent way to practice while creating something fun and interactive. Both projects are structured with starter code containing function definitions, convert temp, and guess game, respectively. Your task is to implement the logic inside these functions. Notice how we're using the def keyword to create our functions, followed by the pass statement, which you'll replace with your implementation. These projects are designed to reinforce everything we've covered so far: variables, user input, conditional statements, loops, and basic Python syntax. Take your time with each one and remember, clean, well-documented code is just as important as functional code. I encourage you to start with the temperature converter, as it's slightly more straightforward, then move on to the number guessing game once you're comfortable. Don't hesitate to reference our previous examples as you work through these challenges. Fantastic progress, everyone. You've completed Module 1. Before we wrap up, I'd like to preview what's coming in Module 2, which will take your Python skills to the next level. We'll begin with control flow, diving into if statements and loops, the building blocks that let your programs make decisions and repeat actions. We'll explore complex conditions and master loop control to create more sophisticated programs. Next, we'll tackle functions and modules, where you'll learn proper function design and how to work with parameters and returns. This is crucial for writing clean, reusable code. We'll also cover module organization, which will help you structure larger programs effectively. Finally, we'll explore data structures, including lists, tuples, dictionaries, and sets. These are the fundamental tools you'll need to handle complex data in your Python programs. You'll learn how to choose the right structure for different scenarios and how to manipulate them efficiently. I'm excited about Module 2 because this is where your programs will really start to come alive with more sophisticated logic and organization. Everything we've learned in Module 1 has built the foundation for these more advanced concepts. Before we wrap up today's module, I want to equip you with valuable resources that will support your Python learning journey. The resources are organized into three essential categories: documentation, learning, and practice. In the documentation section, you'll find the Python docs. your comprehensive reference guide that includes complete documentation, official tutorials, and the standard library reference. The PEP 8 guide is particularly crucial as it establishes coding standards and best practices that professional developers follow. For active learning, I highly recommend Real Python, which offers in depth tutorials, video courses, and practical code examples. Python.org provides official resources and hosts vibrant community forums where you can connect with other learners and experts. To sharpen your skills, Exercism offers guided learning with code review and mentorship opportunities. Leet Code is invaluable for those preparing for technical interviews, offering coding challenges that range from basic to advanced. I encourage you to bookmark these resources and make them part of your daily programming practice. Remember, becoming proficient in Python isn't just about watching tutorials, it's about actively engaging with these resources and practicing consistently. These tools will serve as your companions long after this course ends, supporting your growth from beginner to professional Python developer. Before we wrap up Module 1, I'd like to outline your next steps to ensure you're fully prepared for what's ahead. On your immediate agenda, you'll want to review today's core concepts while they're still fresh in your mind. Complete the assigned homework exercises. They're specifically designed to reinforce what we've covered. I strongly encourage you to explore the extra resources I've shared and, most importantly, dedicate time to practice coding. Remember, programming is like learning a musical instrument. Regular practice is essential for mastery. Looking ahead to Module 2, we'll be diving into some exciting topics. We'll explore control structures that give your programs decision-making abilities, work with functions and modules to make your code more efficient, and learn about various data structures that are fundamental to Python programming. We'll also cover file operations for handling external data and exception handling to make your programs more robust. Take some time this week to experiment with the concepts we've covered. The more you practice now, the better prepared you'll be for these upcoming advanced topics. And remember, coding is an iterative process. Don't aim for perfection, aim for progress. And here we are, at the conclusion of our first module in Python programming. I want to express my sincere gratitude for your active participation and engagement throughout this session. This foundation we've built together, from understanding basic syntax to completing our first calculator project, will serve as the cornerstone for your Python programming journey. As you can see from the Python logo on our final slide, we've only scratched the surface of what this versatile programming language can do. The skills you've acquired today, working with variables, understanding data types, and implementing basic operations, are just the beginning of your programming adventure. Remember, programming is like learning a new language. It takes practice, patience, and persistence. I encourage you to experiment with the concepts we've covered. Try the additional exercises in your course materials, and most importantly, don't be afraid to make mistakes. They're an essential part of the learning process. In our next module, we'll build upon these fundamentals and explore more advanced concepts. Until then, keep coding, stay curious, and thank you again for your attention and enthusiasm.